Hi, I'm Alex Sir, and I'm here to talk to you about dovetail inspection and cutting. So dovetailing is used in many precision machining operations. We see it on a lot of our machine tools. We see it in firearms. We see it in precision indicators where we want to maintain a specific orientation, but we want to be able to move it in a different axis. So how you cut a dovetail is we cut out the inner slot dimension with a standard end mill first. We don't just take that, we're not going to just take so if this is your dovetail, we're not going to just take our dovetail cutter right down through the middle there. We're going to take a standard end mill and clean up this portion first. And then we're going to come in and gradually make larger and larger cuts with our dovetail cutter. With this PowerPoint, we only use conventional milling when cutting a dovetail. And similar to threading, it's a form tool. So we want to slowly enter the workpiece, and we need to gradually decrease the depth of cut each time. I think it's 10 thousandths that I used to suggest is a little low, especially if you have like an insert dovetail cutter. I would start with probably like 50 or so. But I would not recommend on an old high-speed steel cutter burying that, because you're most likely going to stress it and break it apart. So the other thing is to make sure you're cutting equal amounts off both sides of that slot, which can be tricky if you get into a standard machine tool with backlash. So you have to really watch that you're cutting equal sides on both portions of that. So the big lesson for the day is the theory behind the math. So we want to be able to measure here to here. That's how dovetails are typically dimensioned. We can easily measure that slot we cut with the bigger end mill, but how do we go about making sure we're measuring this well? And a lot of people would want to use calipers, but that is not a very accurate method, because you can end up with them crooked. They're not going to actually get to the points. So this is going to be very similar to how we measure our 3-wire measurements on threads. So we're going to use 2 pins, and you can pick whatever diameter pin you want, as long as it sticks you out past this point. And we're going to then know our radius of our pin. So we're going to know this side of that triangle. So this is an imaginary triangle in here that we've created, but we're going to be able to solve for whatever we need. So there's the stack up of how we're going to measure between there. Okay, explain it a little more. So here's the right triangle we've created. If I had a 60-degree dovetail, the pin is going to bisect that angle, so I'm going to have a 30-degree angle on my triangle. And if I have a 1/4-inch pin, that means I have an 1/8-inch radius on it. So the way that this is set up, because this is my working angle, I'm trying to find my adjacent, and I know my opposite side. I'm going to use tangent of 30 is equal to 125 over A for adjacent. So now I need to get that by itself. So I'm going to do adjacent over 1, adjacent over 1 to the other side of the equation, because we always have to balance everything out. Now I have a tan of 30 is equal to 0.125, which still doesn't really help. So we have to split the unknown A from tangent of 30 by dividing. So that's going to cancel those tangents of 30s out on that side. So this is what our equation looks like now, with A is equal to 125 over the tangent of 30. And when we type that all in, we get 216 thousandths for that unknown side of that triangle, the adjacent side of our triangle. So here, if I didn't know what my caliper reading was supposed to be, so it was a blueprint specified tolerance, and so I know it's supposed to be 2 inches, I would take what I just calculated with my 216 thousandths, and I would add the 125 there, and I would just subtract all of that from 2 inches, and that's going to give me my caliper reading that I should be getting. So 2 inches minus, you just have to make sure to do it twice, right? The 216 5-1 twice as the 125 twice, and we end up with 1.31698 is going to be my caliper reading in this example. My unknown overall length here, say I come upon a old dovetail, I want to build a mating dovetail to it. I wanted to make a dovetail holder for my lathe. Well, I could easily measure with using 2 pins. I could figure out all of this using the right angle trig. And then I would measure with my calipers, and we'd merely add it all together. So I would take my 21651, my 125, and I'd multiply that by 2, okay? And I would get my 2.18302 for this example. So